My cool chemists, it's Jono from Seneca, and today I'm going to be breaking down polarity for your A-level chemistry exam. If you're an avid listener of these episodes, you'll know that this episode was hinted at in a previous episode when I was talking about physical properties. So the suspense is over. We're now diving in and talking about all the things you need to know about polarity for your A-level exam. Let's get going. Some bonds within molecules can be described as polar, and this is due to a difference in electronegativities. Electronegativity. In a bond between two unlike atoms, one atom will have a stronger attraction to the electron pair than the other. This means the electron pair will not be at the center of the bond. This causes the buildup of a partial charge on one atom, and we can write this as delta plus or delta minus depending on the charge. That delta, it's lowercase, it looks a bit like a sperm cell, but like an accessible one. And you put a plus or a minus next to the delta sign, and that tells us whether we have a positive or negative partial charge. The ability of an atom to attract the electron pair is called electronegativity. The value of electronegativity can be measured on several different scales. The one you need to know about is the Pauling scale, named after Linus Pauling, the inventor of the scale. The most hard word to say sometimes. The most electronegative element is fluorine, which has a value of 4.0. Other strongly electronegative elements are oxygen, coming in at 3.4, chlorine at 3.2, and nitrogen at 3.0. Carbon has an electronegativity of 2.5 and hydrogen of 2.2. The most electronegative atom in a bond will develop a partial negative charge, delta negative, and vice versa for the positive one. This charge difference is called a permanent dipole. A good example of a polar bond is the HCl molecule. And a good example of a non-polar bond is the CH bond, because carbon and hydrogen have very similar electronegativities, which means the bond will not be polar. So do we remember if a bond has a delta positive and a delta negative on either atom, what do we have? We have a permanent dipole. And what was the name of that cute little scale to measure electronegativity? It's the Pauling scale. Some people might say Pauling. I say Pauling. Pauling scale. So it's like Paul with an ing on the end. Next, we talk about some polar molecules. Molecules can have overall dipoles, just like bonds. So molecules can also be polar. A requirement for a molecule to be polar is that it has polar bonds. Seems to make sense. If there is a charge separation between one side of the molecule and the other, there will be a permanent dipole. A good example of this is something like chloroform, which is CHCl3. Let's get into some finer details. A molecule with polar bonds is not necessarily polar. Plot twist. I know, I'm still recovering. If the bonds are arranged symmetrically around the center, then the partial charges will be the same on either side of the molecule. Such a molecule is not polar. A good example of this is something like tetrachloromethane, which is CCl4. So in that molecule, the C to Cl bonds are polar, but that molecule is going to be symmetrical, so those dipoles cancel out. So to be a polar molecule, you need asymmetry and you need polar bonds. So a nice little flowchart you can think of in your head if you're trying to decide whether something is polar. Article 1, are there polar bonds? Remember, we get polar bonds whenever elements with different electronegativities are bonded together. Then you've got to check, do those polar bonds cancel out? Is the molecule symmetrical? If it is symmetrical, honey, it's non-polar. If it's not, we've got something polar on our hands, okay? And do you remember how to define electronegativity? That is the ability of an atom to attract a pair of electrons. The CH bond, is that polar? No, it's not, and that's because carbon and hydrogen have really similar electronegativities, so we don't get that dipole forming. Then, what are some characteristics about electronegativity? How's it measured? Pauling scale, most electronegative atom, fluorine. And how do we form a polar bond? When we have atoms of different electronegativities bonded together. So that just about takes us to the end of the episode, and I hope you're feeling confident about polarity and electronegativity and all the different things you need to know. The key things I would remember is that if a molecule is symmetrical and has polar bonds, it's not going to be a polar molecule because those the dipoles are going to cancel out. It's one thing that's really key to remember, and examiners love to try and trick you out with it. So don't fall into that trap. You're welcome. Thanks for joining me. I hope this was a useful run through of polarity for your A-level chemistry exam. And I look forward to joining you in the next episode. Bye.